Right, this is my game, Multi-taskr. On the theme of being human, I decided to make it about making projects and sharing them with your community, and the multitasking that comes along with that. So you get into the game, you have 3 meters you need to fill, and 3 meters that constantly go down. You need to use your upkeep action. Depending on what mode you're on, it will be different. You can eat, sleep, and call on the phone to keep your meters up, and then you can collect different bubbles based on the current mode that you're in. I wanted to make it a simple movement system, so there is a jump and a dash that you can use whenever, and that about covers the basics of the game. However, there are further things that go into it once you win or lose. And as you can see here, now that we've finished the game, you've shared your project with your community passionately, and you've been human, and you've shared all your work and your creativity that only a human can do. And that's the game. Now into the code. Now before we begin, I'm going to show off some things such as the animator, which contains states for the sleep, eat and social animations, jumping, walking and dashing animations. These are here specifically so, well, obviously the player can animate, and they can keep track of these variables which are defined in the scripts. And in the game itself, in the game scene, I will go in the order of which I actually made these scripts, and of what I developed in the game first. But in the actual scene there are these variables that switch depending on the animator variables as well, so keep that in mind as we go through. Start off with the player move animation, well, not animation, player move code, definition of all the variables, and the O variables are to keep the original speeds for when it is frozen in place, but I'll get to that later. This is just the start, defines the O variables as the original move speed, max speed and AC time, so obviously it can keep them and redefine them after the freezing. This is basically whenever there is a speed higher than 0, it'll do the walking animation if it's on the ground, so this defines the speed variable for the animator, and the math ABS ensures it's always positive, so since it's the same animation left and right, it doesn't break. This uses something from the meter manager script, which I will get to later, to start the isFrozen coroutine. It's a coroutine because it takes a specific amount of time and needs to be called whenever. This will set the eating, sleeping and socializing animations to true depending on what state you're in, which is also in meter manager, which we'll get to later. It sets everything to not 0, because 0 breaks the game, surprisingly. I did not know that, but it's just set to an incredibly low value as compensation. And it freezes the player for 2 seconds, and then returns everything to the original speeds, and sets isFrozen to false, and sets everything else to false, and it continues. On to the follow mouse script to get the little cursor for the player, as you can see right there. The cursor for the player follows the mouse and aims in its direction, so this is how I did that. Defining variables once again, getting original dash strength and original all that, the camera and the animator and all that things, the rigid body, the player object. This defines the mouse position as the mouse position, which is something that needs to be done. I didn't actually know that for a while, so I thought it was broken, but something needs to be done. Vector 3 rotation, obviously it just rotates the mouse cursor around specifically the player's transform position to the mouse position. So it just makes it so it's always rotating that way. Well, it's not always rotating that way, but it's always in that position. And ROT-Z makes it so it's always rotating towards the mouse, so it's not always in the same position, because if I boot up the game to show you, you can see that, apologies for the loud music, but you can see that it's always rotating to the mouse position instead of just being a static sprite, which is why that is there. And then there's the dash script, which just dashes to the mouse direction by using impulse, setting it to the speed, adding force. only does it when the dash cooldown is lower, of course, and it's not already frozen. And also, it freezes, yet again, there's another free script that does about the same thing, except it sets the dash strength this time instead of the speed, and the jumping script will also have the same thing. 3 separate scripts because I couldn't find a really easy way to do it all in one script, so I've just done it in 3. It does about the same thing anyway. The dash is done in a coroutine and sets the animator so it's dashing. I did this, it didn't need to be in a coroutine, but I thought it was easier for it to be there because it doesn't work as consistently with the animations if it wasn't in a coroutine. I'm not entirely sure why, but I found this as a solution, so it does work. And it just adds the force in the direction of the mouse, and it determines how long the animation goes for with this little wait per second, so the animation always lasts at least a frame. And then the dash G sets the animation false and all that stuff. Onto the jump animation, defining variables again. Setting the is dashing variable, so it's like the is dashing variable is in this as well, so you can't do the dashing animation while you're jumping. It took a lot of tweaking to get that working. To get, like, press W and you jump if you're not grounded or frozen, and it just adds jump velocity. Jump is set, and also O jump is set, so it's kept while it's frozen in the coroutine. Same thing again. You can only jump when you're on the ground and your velocity is lower than 30. Your upwards velocity is lower than 30, obviously. And you can only, like, when you exit the ground, it sets grounded back to false, so you're always only grounded when you're on the ground. Took a while to get that one working, but it does work. After that, I did the spawner script, which spawns the falling things from the sky from these white circles. So it would spawn at random one of the 3, and the player interacts with them depending on what mode they're in, which is done in the meter manager script, which I'll get to in a minute. I replaced the update function with a coroutine to prevent spawning lots and lots and lots of things every frame, which I ended up doing, and it lagged the game a lot and crashed it a lot, so I had to figure out a solution, which is when I started using coroutines. And I went back and implemented some in the other ones as well, and just made it all consistent and made it better. And also I just used the quaternions to set the object rotations the same as the parent, so it's not at random rotations as well, where they don't like rotate when they hit something. Locked rotations as well in the Unity menu. And in the meter manager, which is the big bulk script that gets all the game logic working, lots of definitions, lots of public statics, so they can be accessed in other scripts. These are the ones that go down. These are the ones that go up, so they start at 0. There's the audio clips for the correct and incorrect things, where if you hit it with the wrong mode, it plays an incorrect noise. You hit it with the right mode, it plays the correct noise. This defines when you lose, depending on when your things hit 0. This defines when you win if all of them are 100 at once. And this defines the state you're in. So if I press 1, I go to state 1, press 2, I go to state 2, press 3, I go to state 3, and I'm always default in state 1, so there's no state 0. And then this is a on collision enter, so it's whenever you hit the bubbles it destroys them and adds +5 to the value. And it plays the audio that was previously defined, and if you hit the thing in the wrong mode it plays the wrong clip, but it depends on the clip. Then there's the tick down, which is basically a coroutine that's like a timer, so every second, every 2 seconds it ticks it down by 2. And then it does a debug, so I know that things are going down, which I haven't had to use for a while because I've known it's been working, but the debug did help a lot during the coding process. And then the final things, actually not the final, there's more. These are the sprites on the side that change with the mode. As you can see, if I go into the game and load it again, they will change depending on the mode I am in, which is just to help the player keep track of what they're doing and how they're doing it and such. There's also these bar scripts, which are in their old folder. They could have been one script. I did not have the capabilities to make them all one script at the time I made them, and I did not go back to update them. But they are for each value. Each bar has a different script to calculate it to a different meter from the meter manager script. And then those are all just in the scene right there. Well, they're not in the scene right now, but they'll be in the scene if I load the game. Don't know why I'm circling something that doesn't exist. But yes, there they are. And those ones will appear when they actually have value to them. And then the final things I worked on were the menu scripts, which is just a bunch of buttons that are in the Unity editor that I apply
click functions to, public void functions. So it's on main menu click, load main menu screen, on tutorial click, load tutorial screen, on quick click, quit the game out if it's Unity editor, if it's an application, just quit, and scene manager, just load the scene, game scene, and start click. So you always start in the main menu, in the exe file version of the project. And yeah, that's basically everything. The game was quite challenging to code some parts of it, but I found out that it's just a bit of trial and error, that's all it really is. But yeah, there's a game.